Welcome to yet another episode of HVACR Verse. I'm your host, Kevin Stiles. It doesn't change unless I got one of the little ones with me. So I'm going to hit a little hot button today and talking about combustion testing. We're rolling into that time of the year where we're going to be testing furnaces, and a lot of guys tend to think that it's not really needed to have a combustion analyzer. And let me say, have a quality combustion analyzer. I know a lot of guys have the Testo combustion analyzers. That's great. I'm over them. I just had the third one fail. I'm done with it. Tired of sending them in. It's over. I'm going to go to a different one. I'm going to get the Fieldpiece Cat 85. But with that being said, make sure you get yourself a quality combustion analyzer. I definitely would not recommend the UEI. Sorry, UEI. I can't. It's garbage in my opinion. So combustion testing is actually required in several states. There's some states where you have to have an annual inspection on your furnace or boiler. Here in Arizona, we really don't come across too many boilers in the residential market. You have it on the commercial industrial market, but not here in Arizona. You don't come across too many houses like that. But a lot of guys I come across, they just think, oh, is it heating? Is it working? Am I getting a flame rollout, etc.? It's good. When in reality, it really probably isn't good. Just because you're not getting flame rollout doesn't mean that there's something unsafe in there. Doesn't mean you don't have a cracked heat exchanger. Doesn't mean you don't have CO spillage. It doesn't mean any of that stuff. And so many people are just so confused by it. And I'm going to be taking everything today that I'm talking about from what I call the Bible of combustion analyzation. This is the Bible, in my personal opinion. If you've never heard of NCI National Comfort Institute, check them out. I'm not going to lie. The course is expensive, but it is well worth it. The amount of information that you learn, not just about boilers and furnaces, water heater combustion testing, boiler combustion testing, range appliance combustion testing, chimney combustion testing for fireplaces and stuff. It is a lot of information, and it is well worth it. There is so much that I thought I knew that I was missing a lot more until I took that course. And I am grateful that I took it and did everything with it. So I'm going to be pulling everything from out of there. No mythical, magical, made up mumbo jumbo. This is all from Jim Davis. If you're not familiar with National Comfort Institute, Jim Davis is the president. But this book has so much information, not just for air conditioning, but also for plumbers that are doing water heaters and stuff like that. There was so much that I didn't even know that we should be doing that is not introduced and mandated or regulated. Now, I know there are some municipalities around the country that require your furnace get inspected once a year, and you have to do a little printout receipt and attach it with it. I just want to go over some facts on combustion that most people don't realize. People will say, well, I have a carbon monoxide. Sorry, I'm opening up my field service book here to get the information to make sure I'm not spouting off hot garbage. Give you factual information. I had the page highlighted and now I can't find it. Right here. So there is a difference between a carbon monoxide detector and a carbon monoxide monitor. Everybody thinks that just because they put these carbon monoxide detectors that they're safe. That's not the case. So 1 to 4 parts per million, normal levels in the human tissues produced by your body. 3 to 7% part per million of CO, 6% increase in the rate of admission into hospitals of non-elderly for asthma. 5 to 6, significant risk of low birth weight. 5 parts per million is the first visual display on a low-level monitor. So the difference between a monitor and a detector is, I believe a detector, and let me just verify. So a detector does not go off until it's been at or above 70 parts per million for 1 to 4 hours. Now, let's say that level dropped to 69 parts per million. That timer resets. So that detector can be going, it'll never go off because you may get to 70 for like 2 hours and then go down to 68 and then go right back up to 70 for 2 hours. It'll never go off. Versus a monitor at 5 parts per million, a good low-level CO monitor will start displaying a visual display on it saying, hey, there's a problem. 9 parts per million is the ASHRAE standard for allowable spillage from vent appliances indoors for 8 hours exposure daily. By what they mean from that is your stove, your oven for your gas range appliances. 10 parts per million is the outdoor level of CO found associated with significant increase in heart disease deaths and hospital admissions for congestive heart failure. 15 to 20 parts per million. I'm just going to start skipping into the highlighted sections. First level World Health Organization list as causing impaired performance, decrease in exercise time, and vigilance. At 15 parts per million is the first alarm you get out of a quality low-level carbon monoxide monitor. And then you get to, ready for this, 25 parts per million is your parking garages. 27 parts per million. That's when you have 21% increase in cardiorespiratory complaints. 30% parts per million. Earliest onset of exercise-induced angina. The first visual display on a UL 2034 approved CO alarm, and it must not alarm before 30 days. We'll skip over 70 parts per million is the first alarm level of a CO alarm for 1 to 4 hours, and it will reset if it's fallen below 70 after 30 seconds. If you hit 70 parts per million on a low-level carbon monoxide monitor, it will not let you silence it. It'll continue to go off. 100 parts per million is the maximum CO level during run cycle in all vented appliances, stable maximum CO for all appliances. Start, run, / shutdown. 400 parts per million, that's when, as adults, we'll have headaches within 1 to 2 hours, life-threatening after 3 hours. This is when you die. This stuff's serious. Like CO, they say is odorless and can't be seen. Sometimes I feel like I can smell CO, especially if I'm cooking on my grill. I can smell that propane burning. You can smell CO, I personally feel. But these are just some facts that CO is dangerous, right? CO is killer. It'll kill people. And if we're not doing carbon monoxide testing, combustion testing on furnaces, water heaters, whatever we're working on, we're not doing the community a service. We're just kind of collecting a paycheck. Now, like I said, get yourself a quality combustion analyzer. I'm not going to tell you what's the best one out there. I think the Sourmans are great, but once again, a lot of the Sourmans, just like I'm running in with the Testos, they're not field serviceable. So you got to send them in, get them repaired, and it's garbage, in my personal opinion. I wish the back racks, you can take them apart, replace your sensors. They're not cheap, but you can replace your sensors. We've recently purchased several Cat 45 and Cat 85 field piece combustion analyzers, and I'm going to say I like them. I like them a lot. I don't know if they're the best yet, but they do come with a 5-year warranty on their sensors, which is pretty good because no other company offers a warranty on their sensors for 5 years. With that being said, I'm going to move it on over to another screen and go over. Well, first let's go over. I have a question. How many guys are actually performing combustion testing? And how many guys know what it actually means? Because a lot of people have told me, "Oh yeah, I know what combustion testing is, and I know how to do it." And then when we actually get to doing it, they really don't know what it is, and they don't know what anything means. Let me see if I can find it on here. See if I can find this photo, and I'm gonna post it up. Give me 1 second. Let me find this real quick. So I want to share this with you. This is a screenshot from a service technician today. And this right here, that is scary. Now, most people would say, "Oh, that's just an overfired furnace," but we're missing some key things in there. We're missing what's the draft on that? Because if that CO was continuing to rise and our draft wasn't correct, we would originally say, "Hey, look, this thing's overfired," but I wouldn't go with overfired, depending on how long they ran it. This right here, this 379 on the stack temperature, sure, it's a little high, but I don't think that's like the max, because that's not where we're at for maximum. That's just 402. 402 is like the max stack temp you want on an induced draft furnace, right? See if we can get this to fix here real quick. All right, I won't let my phone close this time. So 379 is pretty high on the stack temp, but he's only been running for 2 minutes and 18 seconds, and that can continue to rise. In reality, once he got to 400 parts per million and he kept rising on his CO, it should have just been shut down at that point in time. Because this number right here is in excess. It is insanely high. I'm not sure where it started. I don't know what the draft on this flue is, because we need to be between negative 0.01 and negative 0.02. Not a positive. We need to be in the negative water column, because on induced draft furnaces, it is in a negative pressure. But this 1.8 on the O2, that is really unacceptable. This could be anything from a partially clogged flue, some debris inside the inducer. There could be a lot of things going on with this, but this is unsafe. Now, with that being said, that doesn't mean turn it into a scare tactic. Don't scare the customer and go, "Oh, you're going to die. All of you are going to die today." Don't do that. That's not the right thing to do. That's unfair. That makes us as technicians look incompetent and like we're trying to scare people into doing something. Don't say you need a new furnace. Give options. Now, did he try to adjust the gas pressure? I don't know. I would have tried to throttle down the gas a little bit to see if my oxygen started to come up and if my CO started to come down. If I would have known the draft pressure, that's where I would have gone with if my draft was correct. But that furnace is unsafe. Technically, that's a red tag. That should be tagged, and it needs immediate repair. And by red tag, I mean, let's go to that in this little book here. Because I know someone's going to ask, well, what's red tagging for states that you don't really deal with this too much? Here, it's not a requirement, but you should, because it's a liability thing for you guys. Not doing your due diligence. So, red tag is based off of safety standards per the American Gas Association, the Canadian Gas Association, whatever, ANSI, and NFPA, National Fire Protection Agency. The violations that start for red tag requirements CO rising, vented equipment spilling into dwelling. We're not dealing with vented equipment too often, and by that I mean like stoves, ovens, and stuff like that. We're not being called in for combustion checks on those. CO over 400 parts per million maximum flue gas level for our equipment. Once we hit past 400, that thing should be red tagged. There should be some solutions on what to do. And I'm going to go over that here in a second over from the book from NCI. If you have unvented, like non-flue stuff, anything over 200 parts per million, that's your maximum. Delayed ignition, excessive flame rollout, that's a red tag. There needs to be an immediate action repair on that. Fuel leaks, gas valve, piping fittings, we should be red tagging that period. You should be turning that gas off and making it so that equipment can't operate without a tool to put it back into operation. Just simply turning the gas off does not constitute making that equipment inoperable. Now, if you make it to where you have to have a tool to operate it again, to put it back together to make it operate, and you document everything and you have photos, because we're in the digital age, baby, and we can document everything we did, so that way if the customer hurts themselves or becomes sick with CO poisoning, they can't come after us or you. They can't blame you because you did your due diligence. You gave them the options. Now, don't just do it and be like, you guys are screwed by a new unit. Fire hazards, improper clearance to combustibles. I see that a lot in garage units. Cracked heat exchangers. CO does not have to be present for a cracked heat exchanger. I'm going to explain that one in a second. A cracked heat exchanger is an automatic fail red tag. Shut gas off. Do not pass go. Do not collect $200. Do not put yourself in that situation. Not only is it unsafe for you and you can wind up in jail, because people do go to jail for this stuff, but someone can die. Someone can die from this. Unacceptable flue installation or deterioration. If you have a big old hole in the flue, it's a red tag. If your flue does this, if you don't want to correct it, I'm turning the gas off. Red tag. That's improper flue. If you have bellies in your condensing furnaces, red tag. So those are 90%ers for you guys that call them that. Failure to red tag and issue severe warning can be considered negligence and creating endangerment to occupants. Red tag procedures, specific actions that must be taken whenever a potential hazard this condition is detected. CO rising, spilling into the space. There's a way to test for that. I'm going to go over that. There's a way to test for CO rising and spilling into the space. CO over 400 parts per million when it's a vented piece of equipment. Unsafe. CO over 200 parts per million unvented. We really don't deal with too much unvented equipment in the HVAC industry. Delayed ignition, fuel leaks, fire hazards, other unsafe conditions. Always consider the following. If the occupants are injured by the appliance, you're liable. You must get authorization to do full diagnostic testing to pinpoint the problem. Don't just say you have a problem and not pinpoint the problem. You have to get authorization, though. You have to say, hey, look, there's a problem. Let's figure it out. You must get authorization to make immediate repairs, because you can't just do repairs and expect someone to pay. They have to know that you're going to be doing that, what you're going to be charging. There are some cities or municipalities, I'm not going to say the whole entire state, but there are some municipalities across the country that require you to contact the authorities, certain authorities, like whether it be the gas company, fire department, something, if you're going to red tag a piece of equipment. Vented heaters producing more than 400 parts per million, the red tag. Unvented heating appliances exceeding, or vented water heaters producing more than 200 parts per million, red tag. Unvented heating appliances exceeding 200 parts per million, and yeah, we're not dealing with that because we don't deal with appliances in the HVAC industry too much, guys. Now, there's an asterisk in this, and I'm going to put asterisk very loosely. May continue to operate if venting poses no immediate danger and a low-level CO monitor is present. Gas ranges may not be within the authority of an HVAC contractor to disable. gas ranges, not furnaces. But if it's over 400 parts per million and it's properly venting still, and they have a low level carbon monoxide monitor, it says you don't have to red tag it. You don't have to disable it, I should say. You should still put some information in there, safeguard yourself, do your due diligence, tell them, hey, what I did, and this is what needs to be done. Whether it be, I don't know, a whole new heat exchanger, whatever the problem may be. So let's move over to this right here. So this is going over the combustion test procedure for an induced draft system. Now, when by induced, we're talking about 80%ers, right? So we're talking about 80%ers on this. I'm going to blow through this. Preparation, follow NCICO preparation and arrival procedures, including visual inspection, warm-up analyzer, enter the building and check CO levels. Test ambient CO near furnace to ensure safety and turn furnace off. If you smell gas, turn off gas. Do not proceed until gas leak is corrected. It's common sense, guys. Also, before I start my combustion test, I'm also doing like my checks to make sure my hot surface igniter is working, all the stuff that I have to shut it down to do. I kind of go through that first. So, but you need to make sure your combustion analyzer is calibrated before you go inside, because you want to make sure that it's reading proper oxygen and not reading some false levels of CO. So you inspect for rust, dirt, soot, inspect condition of flue. Like I said, bellies. Do you have bellies in your flue? Does your flue slope downhill, then back uphill? Because that's incorrect. Drill a 5/16. Do you have a metal flue on a system that should have a PVC flue? Because that is also considered in the condition of flue. Sorry about that. I had a technician trying to get a hold of me. I had to pause this for a second. But you need to make sure that you're using the proper materials for your flues. Just last year, I had a technician send me a photo. They had a condensing furnace, and the installing contractor did not put in the proper flue, and there was all that white calcium buildup. It's actually carbonic acid, and it was corroding away the flue. And if the technician's like, the family that's in the house, you can see the photos, and they said these photos were like a year old, and they look like 20 years older than those photos. So they were getting CO poisoning, and when he did a CO test of the surrounding area, it was like 26 parts per million, which is insane. That's dangerous. That's killing you slowly. And they were saying they were having complaints of headaches and stuff. Do the right thing. Make it correct. So first, you do all the inspection of the flue. Then you drill a 5/16 combustion test hole in flue. Now, we're talking about condensing furnaces here. Not condensing furnaces. Induced draft furnaces are 80%ers. So test hole in flue, 12 inches above the inducer fan. If there is an elbow near, drill the test hole 12 inches past the elbow. Then drill a 1/4 inch test hole for draft test in the flue, 18 to 24 inches past the inducer. So you can check your draft and your flue at the same time. There's some combustion analyzers that do it all in one, and that's great. So for combustion testing, you insert analyzer probe, start the furnace, and begin testing. Now you're going to record for your light off. And a lot of guys will freak out because their light off shoots to like 1,000. That's normal, that's fine. Measure and record highest CO levels during the first 60 seconds of operation. CO levels should not exceed 80 to 1,000 parts per million. Then should fall below 100 parts per million within 3 minutes. Note, high reading on test report. Well, I'll show you a test report for this. You position the probe in the flue to find the highest CO parts per million and the lowest O2 percentage. Take CO and O2 and temperature readings at this point simultaneously. Do this all at once. This is just going over what you're supposed to be doing. Repeat the CO and O2 readings at least twice over the next few minutes while the furnace is still operating. Record the test results. Ideally, CO and O2 levels should remain within range and stable. If CO level rises or exceeds 400 parts per million, shut the system down and propose repairs. Shut off furnace and continue to test CO levels for 1 minute. Readings may spike momentarily, but should drop near zero through the test. Rising CO indicates you have a leaking gas valve. So if you turn that furnace off normally, like you take the Y off and take the heating signal away, you're going to see that CO, it should be dropping. It should not continuously slowly climb, because if your CO is slowly climbing, your gas valve's leaking by, and that's a problem. That's why that test is saying that. We'll go over the temperature testing, draft testing. It says while reading CO and temperatures, also read and record draft. Minimum draft pressure should be between negative 0.01 to 0.02 inches of water column. You can be a little bit higher on your draft pressure. By this, I mean you take negative 0.04, still okay. That's just flowing faster. Seal and complete repairs and testing, diagnose readings, agree on repairs, price terms, whatever. This is just a sales thing. I'm not really here to talk about sales, guys. I'm here to talk about furnace safety. So that's the thing for, they're telling you how to do it for induced draft furnace. This is for condensing furnaces. Similar operation. But if you notice on a condensing furnace, they have this little 4 right here. That's not right. It's actually 800,000 parts per million. This should fall below 100. Same similar things, but what we are not checking for on a condensing furnace is our draft. Because draft doesn't exist on condensing furnaces because we're taking and we're creating a positive pressure, and it's a power ventilated system. So, similar things. This is going over flue gas spillage, how to test for flue gas spillage. The purpose of this test is to determine if flue gases are spilling from the equipment and not being carried out of the flue. My technician should have done this earlier today, and I couldn't get a straight answer to figure out if he actually did this. Place a thermometer probe just inside the furnace door by the burner manifold. If burner access door has only louver openings, insert thermometer probe in louver as low as possible. On rare occasions, a hole may have to be drilled into the door. Turn furnace on and observe the temperature after 5 minutes of operation. This temperature should be 100 to 140, assuming some radiant heat. If the temperature is higher than this, is an indication that flue gases are partially spilling out of the burners because of a venting problem. Because you're not getting rid of that flue gas, it is spilling back through the burners. You can have flue gas spilling back and not have your flames rolling out. Temperatures in excess of 200 degrees indicate a more serious and immediate problem. Shut that thing down. Save yourself. So that's for a furnace. I'm not going to go over boilers. I'm not going to go over water heaters. We're talking furnaces here. So what I do want to note, when you're doing your tests for furnaces and your combustion testing, you should be doing everything as if the system was normally operating. By that I mean doors on. If you're in an attic, the attic access hatch closed, crawl space hatch closed, to make sure you're getting the proper O2 in that area. Because I've seen furnaces operate when you show up and you're like, oh man, service call. It's happened to people before. They show up, everything runs, and then they close everything up and then they leave, and the next day customer's saying the heat failed again. And then come to find out, it's something's blocking air into that area and they don't have enough free oxygen. And guess what? You had the hatch open. Let's say you were in an attic and it was pulling the air from the house to give it that air it needed. And this happened to someone that I know, and they wound up closing the hatch on accident and then found that that furnace was starving of oxygen because of that. And the customer had recently spray foamed their whole attic. So all their fresh air intakes on the outside were foamed in. So this is a report for combustion testing on a furnace. This is copyrighted by National Comfort Institute. As they can see, that's all there showing. It's their proprietary stuff. This form works, guys. It works great. Light off. This is when the unit first fires up within that first minute. This is your highest reading, goes in here to your light off. We're not looking at the O2 in that first minute. We're not looking at the flue gas temp. We're not looking at the supply air temp. Test 1. That is minute number 2. So that next 60 seconds afterwards, what is your CO levels at? What is your O2 levels at? We're not looking at flue gas temp because it's not been running long enough to get an accurate flue gas temp. That's what we call stack temp. Then we haven't been running long enough to get an accurate supply temp. Test 2, same thing. That's your third minute. So for that third minute, you're seeing where it's at. And then you write down your readings right there. Then you get to minute number 4. Minute number 4 is where you go, okay, CO level, oxygen level, which is your O2, stack temperature, supply air temperature. So on a induced draft furnace, we should be 6 to 9% O2, 100 to 140 degrees on our flue gas, and 130 to 140 on our supply temp. So we got through minute 4. We pull the W circuit off, let the furnace turn off naturally, and we watch that final shut off. Watch it shut down. If your CO is climbing slowly after shut off, got a problem. Your gas valve's leaking by. So what I can say is, while I'm doing this test, before I do my final test, what I do is I disable my blower for a few seconds and I make sure my O2 doesn't drop. And then when I plug the blower back in and it doesn't rise back up, because that's an indicator that you have a leak inside your furnace. Your heat exchanger is leaking because you're pushing air into it. So that's an indicator, just a little tip of trick there. This just goes over, and I'm saying, guys, just for the love of God, find out where this class is being given at. I've had people from other states that I've seen out here taking this course because they want it so bad. And I'm in Arizona, and there's people coming from Wisconsin. There was a guy from Ohio. There was another person that came from New York during the class. There was a company that's like had all 6 of their employees come out here for this class. If you can get this class or convince your employer to pay for this class, take it. And I'm saying it's not cheap because it's not. It's over $1,000. So, but it tells you CO's rising. So the CO action is going up. That's what I mean by rising. Your oxygen is falling. Your supply temperature is over 140 degrees. Your flue gas is over that recommended range. You have an overfired furnace. Now, my technician earlier today could have had an overfired furnace, but I would need more information to discover that. Underfired, we're not looking at parts per million because our CO is going to be low no matter what. Our O2 is over 9%. Our supply is under 130 degrees. Our flue gas is under 100 degrees. If the problem with an underfired furnace on 80%ers, guys, on induced draft, you start condensing. And you don't want to condense on an 80%er. Venting problem, we have rising CO. Once again, the action as it's rising. My O2 is falling. I'm not looking at supply plenum temperature, and I'm not looking at flue gas temperature. This is why I say my technician earlier may have had a venting problem, but I don't know what their flue draft was, and they may not be escaping those gases out fast enough, and that may be the problem. But once again, you need all your information to get all that down. So if you notice this whole area here for an 80%er is grayed out because we're not looking at combustion air because we don't have that on an 80%er. That's our condensing and 90%er furnace. This right here, if you're over 100, but it stabilizes and doesn't like keep climbing, this is what we call a dam problem. It's got a dam problem, guys. Dirt, rust, alignment, mechanical. By dirt or rust, burners are dirty or rusty. Or the heat exchanger is dirty or rusty. Alignment, your burners are impinging onto the actual heat exchanger, hitting the walls, and they need to be aligned correctly, and that's creating that high CO. Mechanical, that's you have some kind of mechanical failure that's causing your CO to stay that high. You just got to figure it out. Then if we have all these are normal, but this right here is over 140 degrees, and this is over 140 degrees, guess what? We're not moving any air. So we may have a supply return static problem, or our blower's not moving fast enough. Could be anything. You're just not moving enough air to pick up that heat. And then it goes over all the stuff for what everything means. But yeah, so that's the essentials of doing, once again, this is all just celly stuff. I don't really get into that. And then, sorry, this was for a condensing furnace. My fault, guys. That's why it's not looking for the draft. Here we go. So now we're looking for the draft on the 80%er. And same thing, we're looking for 0.99, 6 to 9% oxygen, 302 to 402 on our flue gas temp, supply air temp 132 to 142, and then our flue draft is 0.01 inch to 0.02 inch. That's our minimum draft. And it goes over the same things, what happens. This is where we have issues at. So, once again, combustion air problem, low draft, but right here, rising, falling, over, high. We're overfired. Underfired, this is where it becomes a real problem on 80%ers, because this is where moisture can start condensing inside your flues and stuff and creating carbonic acid. That's why condensing furnaces, they use PVC flues, because the acid doesn't eat the pipe away, versus the B vent and the metal vents that we use for 80%ers and stuff. The carbonic acid eats that metal away. But once again, same stuff, recommendations. It's a really good tool. We should be doing combustion testing on all furnaces, not just going, yeah, it's lighting, it's okay. I cleaned your flame sensor, congratulations, you know? No, we should be doing a combustion check and making sure things are working properly and safe, because if you go and do a maintenance on a furnace and you say everything is A-okay, 3 weeks later, someone's kid dies and they determine it came from the furnace and you said it was A-okay, guess what? Someone's coming to look for you. It's not to scare you guys. It's just, let's be real. This is a reality thing. This stuff can be dangerous. I think furnaces are way more efficient than a heat pump for heating. My personal opinion. I know the government wants to get away from gas appliances, but it is probably the most efficient way to heat a house. With that being said, if you guys want to know more about combustion testing, or where you can find NCI classes and stuff, they have more than just combustion testing. They have a lot of great courses. Their airflow dynamics is really good too. I highly recommend seeking it out or finding someone that truly understands combustion testing, because there's a lot of things that people don't really understand. There's a lot of companies that teach bad information, and it's not because they're intentionally doing it, it's because they don't know any better. Just change the way, and that way we all become better. Because if we just continue to do the same stupid thing, we're going to just look like stupid idiots. People already think the HVAC industry is a bunch of jokers, right? So, but if you guys have any questions about it, or in this book, there's also on like how to tell what the BTU output of a furnace is. Like it's telling you how many BTUs it's actually doing. I can go over that. I really don't do the clocking of the gas meter thing, because clocking of the gas meter, in my personal opinion, is okay, but it doesn't really tell you BTU input content, because BTU input content is based upon the type, how clean the fuel is coming to the house, that area, does it have an excess amount of oxygen in it? It could be so many different factors. I don't clock a meter. It's not worth it, in my opinion. I'll check to make sure it's getting the proper amount of gas pressure, but I don't clock them. So if you guys have anything else you want to know about these, just let me know. Drop a comment. I knew someone was like, why you have your kids on here? My kids wanted to join in, so I'll let them have a little fun with it. I don't spend a whole lot of time with my family. I spend a lot of time at work, and I spend a lot of time with my technicians. And when my kids want to do something with me that they find exciting and they want to do, I'll let them do it with me, and I'll make them feel important. So I hope everyone is ready for winter, because I feel like summer is over, especially here in Arizona. I think we're going to be like maybe 100 by the end of this week, like a little like 101 or something. And then next week we're in the 80s. It just drops right off the face of the earth. And then winter's right around the corner. I think it's going to be a cold winter for Arizona. But I hope everyone's having a good week, and keep on HVACing on. If you like this video or any of the other videos, hit that like button, subscribe, leave a comment, and as usual, happy HVACing.